right, so we are going to dive into 2.6 right after we finish up 2.5. So what part do you guys still need to do from yesterday?
The last two.
The last two. So let's say go to part 3.
Mr. Hudson.
Yeah.
When you said dive, I thought you said die at first.
No, dive, like head first. Did you guys do the one with Kansas, or are we there yet?
Yeah.
Yes?
We did that.
So we need to do this one?
Yes, we need to do
Okay. So you are planning a neighborhood. The rectangle shown is a scale drawing of the roof of the rectangular building. You use a scale of 2 inches to 75 feet. That is going to be part of your proportion. That's going to be one of your ratios. So what would be the dimensions of the roof in your drawing if you used a scale of 1 inch to 100 feet instead? So the first thing we have to do, and you guys may have seen this on your homework last night, which by the way to talk about yesterday in the assignment. So yesterday was the first time I've ever tried to assign a lesson. So when you get on there, you'll see that the lesson is assigned, which I had meant for her to work through, for you guys to work through on your own. But because she is a math teacher, math is her specialty, she decided to actually teach it to you guys. So you don't have to do the lesson. If somebody wants to bring me their digits and show me what it's having you do, you don't actually have to do the lesson. That won't affect your grade at all. And both homeworks are up there, G and K. You choose which homework to do. And it says on there, choose which homework to do. G is a little bit harder, K is a little bit easier. The mixed review, totally optional, but that will tell you if you are good up to that point, if you are ready for the mastery at that point. Does that make sense? Because the mixed review, say the mixed review for 2.5 would do all of 2.5 and 2.4 and 2.3 and 2.2 and 2.1. And they're normally about 5 questions. So it just puts it all together. So here, the first thing that we see is we have the scale drawing. Can anyone that worked through their homework tell me what you think we need to do first? I'm given the scale drawing. I know the scale that I used to make the drawing. Franny? Yeah, we have to convert either inches to feet or feet to inches. And since my drawing gives me inches, it's giving me the original scale. Notice how color-coded this? These dimensions go with the first scale. So let's figure out what is the actual dimensions of the roof of the building. So I set up 2 inches compared to 75 feet as my initial scale. Everybody should be setting this up. Sorry, there's not a ton of space, but there's some space. You got to learn to write a little bit smaller now. And then the value that I know is 6 inches, and I don't know what the actual width of that roof is. So we're going to say that that question mark is going to be over here. It's going to be the actual dimension. One way that we could solve this would be cross multiplication and then divide to solve. But here it's actually easier than that. How do we go from 2 to 6?
3
times 3. Make sure we use hands, please. So I'll do the same thing on bottom, and my question mark can actually turn into, what's 75 times 3?
225.
225 feet. So that tells me that the actual width of the roof is 225 feet. Then I can use that proportion again to figure out the length. So if I erase this, how would my ratio look now? What do I want to put in here? What do I want to solve for? Bunger?
8 on the top.
8 on the top, and that's inches. Because notice how I'm putting my labels in here. If I start with inches on top, feet on bottom, I have to continue with inches on top and feet on bottom. So then, how do I go from 2 to 8? Crystal? Times 4. And that, bless you, that tells me that this is going to be 300 feet. So the actual length is 300 feet. Does what we've done so far make sense? Notice, this is not our final answer, though. These are what we like to call working numbers. They're numbers, oh, you didn't capture it didn't capture the second one. But you can figure out, it's not in the PDF notes, but it'll be in the video. Sorry, it didn't capture. The actual thing it wants us to do is take, gotta get my smart back here, take these values with this conversion and set up a new drawing and figure out what those new dimensions would be. I have a friend who's an architect. Have I talked about Randy before?
No.
Okay, I have a friend who's an architect. His name is
you have.
Randy. He does a lot of stuff with this, and sometimes architects will have a drawing. Have you ever seen a blueprint when they unroll like a big old blueprint? Blueprints are pretty big. So a blueprint already is a scale drawing, but what if they took the blueprint and they wanted to fit it onto a regular size piece of paper? They'd have to redo all the scales to fit it onto a regular size sheet of paper, because a blueprint, I mean, sometimes blueprints are like as big as the TV. Like really, most blueprints are about that big, as big as the TV. Right?
I did this in art class last year. So
Yeah.
Like a grid thing.
Yeah, and you either scale it up or scale it down. Yeah, so we're gonna now take this ratio, the 1 inch to 100 feet, set that up, and guys, sometimes in your notes, especially as we get further, you may need an extra sheet of paper to do some work on, depending on how big you write. Ethan, question?
Wouldn't the 2 inches to 8 inches be 375 feet because you're adding 2 75s to it? Because 8 is.
So think back to when we had 2 over 75. We're not talking about adding, we're talking about multiplying to go from one to the other. So this is times 4. So I take my 75 and do times 4. 75 times 4 is 300.
Oh, okay, now I get what you're saying.
Yeah, are you good?
Yeah.
So I set up my 1 inch over 100 feet. Thomas, can you tell me what my ratio over here is going to have?
It's gonna be 300 feet on bottom, and then you're gonna divide 300 by 1.
300 feet on bottom, because it's the feet measurement. So I'm essentially drawing a new drawing and trying to figure out what is going to be the new length, what's going to be the new width. So I use the 300 feet to figure out the new length. Well, how do I go from 100 feet to 300 feet? Thomas?
You multiply it by 3.
Multiply by 3. So since we did that there, we'll do the same thing on top. And we get that in my new drawing, this will be 3 inches. Thomas?
I just want to say that what I first did for the 2 inches equals 75 feet. I divided 75 by 2, so I just had to.
So you had 1 inch and see,
divided by
this is a weird number when you divide it by 2 though. 75 divided by 2 turns into like 37.5.
Yeah,
So it's a little bit trickier to work with, but yeah, what you did is totally right. So now we set up the ratio again, 1 inch to 100 feet. Who can tell me what is gonna go in the right side of the ratio here? Eminal?
225 will go on bottom.
Would go on bottom. I use my actual measurement of the building. It's in feet, so it goes on bottom. Now, this multiplication wouldn't be quite as easy. So instead, here, let's take the cross multiplication method. So we're going to cross multiply, and it's a little tricky since I only have 2 colors of highlighter. We're going to cross multiply these guys together. Let's just call this x inches, and we'll cross multiply these. Change color, please. We'll cross multiply those guys. So 1 times 225 gives me 225 equal to 100 times x. Well, that's just 100 times x. What do I do to solve for that x? Isaiah?
Divide it by 100.
Divide by 100. You always divide by whatever's in front of the x. Whatever's multiplied by the x. And that will give us that x is equal. When I divide by 100, I just shift my decimal 2 places. 2.25, and that label will then be inches. Questions on what we've done here? I wish I had more highlighter colors to work with. I might try to see if there's a update or anything that I can get for that. We're all good here? We understand the process? We took the scale drawing, figured out the actual, then take the actual, figure out the new scale. This is where I see people get goofed up on their homework because they want to only do like one step. This is a very multi-step problem. All right, let's try the got it. So if we have two scale drawings of the same object. So let's say we had an object. It was x by y. If one of the drawings uses a scale of 1 to 2, and one of the drawings uses a scale of 1 to 3, which drawing is larger? Yeah?
I think it is 1 to 3 because, like, for every, like, if it was 3 by 3, if it was a 3 by 3 inch square, it would be a 9 by 9 feet square. And if it was just a 3 by 3 square over there, it'd just be a 6 by 6 square.
Okay, so let's think about this. So normally when we give a scale, it's comparing the scale amount to the actual amount. So let's give some values. If my actual was, let's just say 2 by 3. This is not drawn correct. Actually, let's get some bigger values. Let's say 30 to 60. Those are both multiples of 2 and 3, so that'll work out easier. So the first scale of 1 to 2, the scale would be 1 parts for every actual 2 parts. So my first scale here, well, if I have 1 part in scale for every 2 parts of the actual, this would be 15 by 30. My scale is essentially 1/2 of the original. That uses the scale of 1 to 2. So now if I set up a scale drawing that uses a scale of 1 to 3, that means for one of the scale, there are 3 of the actual. So that would be 10 to 20. Go ahead.
The ratios are basically just fractions. So if the number on the denominator was larger, it's instantly smaller.
Yeah, so what Eli said was these are essentially just fractions. So when the number in the denominator becomes bigger, my drawing gets smaller. Because the statement that you could say here is the scale is 1/3 of the actual. Whereas here for the red one, the scale is 1/2 of the actual. Which would you rather have? Half a pizza or 1/3 of a pizza? Half. The half is gonna be more. So whether they're drawn actually perfectly to scale, mine are not drawn to scale correctly, but we know that this drawing, the one that I have highlighted in yellow, the 1/2, that would be a bigger drawing because it's half the actual size compared to the one that's 1/3 of the actual size. So always remember when you set up scale, it's scale compared to actual. If it captures. Sorry, it didn't have its coffee this morning. Are we good on 2.5?
Mm-hmm.
Cool? Understand it?
Yep.
All right, let's move on to 2.6.
I'll pass it out. Okay.
Okay. We do that. What does that smell in here?
I don't
Smells
want
like
to
Mr.
touch
Kabi's
them.
It smells like Mr. Kabi's. Yeah, it's candy. It doesn't stink. It smells good. It doesn't stink. But it smells the pumpkin.
Smells like pumpkins.
Yeah. It smells like Mr. Kabi's. Yeah, it smells like Mr.
It does
Kabi's.
smell cheese.
Yeah.
I have no idea.
Do you
I
have
do
a
have. I have this, but it's not lit. It's like a Febreze can, but I doubt that's what you're smelling.
No,
Okay.
it's hand sanitizer.
No, no.
Yeah, that one's a
No,
little too.
not in the school. All right. So everyone have your notes
Yes, sir.
on the front. So we want to first talk about relationships that are or aren't proportional. So first, this is not on your notes. Let's just check out this situation. A peculiar professor plans a room addition for her pet paper cup and poster. The scale of the model is 1 inch to 3 feet. So this is the actual. Draw a net for the walls and the ceiling of the room on the inch grid. Notice it tells me inch grid. So that means that every width here and length here, each of those are 1 inch. So it's going to be 1 by 1. So I want 1 inch to equal 3 feet. So let's just first talk about what the scale amounts would be. So if I have 1 inch to 3 feet, I can set that up as a ratio. That will be equal to, well, my two of my dimensions are 9 feet. Would that go on top or bottom? Bottom, because I've got feet on bottom. So how many inches would that be?
3.
3, because to go from 3 to 9, we multiply by 3. So this will be 3 inches. Then I can set up another part of the proportion that is going still from my 1 to 3, which I might as well just write it again. So 1 inch compared to 3 feet. I have 12 feet. How do I go from 3 to 12?
4.
Multiply by 4. So I do that on top and I get 4 inches. So now to draw the net. Now who can describe what a net is? Not something you catch fish in. Isaiah?
It's like if you fold it up a net, it'll make a 3D shape.
Oh.
So to turn around what you just said, if you unfold a 3D shape, you'll make a net.
Yeah.
So we want to unfold this 3D shape. Let's start with the front wall, this wall right here, being in my bottom middle. So if that was 12 feet by 9 feet, it's now going to be, well, my 12 feet has turned into 4 inches. My 9 feet has turned into 3 inches. So this is going to need 4 inches across. 1, 2, 3, 4. So there's my front wall.
Mr. Williams to the office, please. Mr. Williams.
But that would actually be this edge, because think about unfolding it. If we take the whole thing apart and lay it down flat, so then it'd be 3 inches up, across, and down, and the door would actually be relatively like here, because we're unfolding it. So then this edge right here is the bottom edge where it meets the floor. What would be the dimensions of that room? Like the floor of that room? Thomas?
It would be like not. It would be 4 by 3 in scaled terms, but in not scaled terms, it would be 12 feet by 9 feet.
12 feet by 9 feet, right? Because that front edge is 12 feet, and then this edge is 9 feet. So I'm going to erase all this. We're now going to draw the floor. So if you can kind of think about looking through that front wall. So it's still 4 inches across the front, 3 inches across the back, because that's actually representing 9 feet. Now, if we want to draw the left side, well, that's 9 feet tall, 9 feet long. So that'd be how many inches by how many inches? We're getting the same volunteers over and over again, so we're going to the cards. Layla? 3 by 3, right? That's off to the left side, so there's my 3 by 3. My right side wall is the same exact thing. So again, 3 by 3, if I draw that well. And then my back wall, Brianna? The same as the front wall, so it's going to be 3 by 4. And then we don't have enough room to draw the roof on there, or the top of it, but that's fine, because if we fold these left and right walls up, the front and back walls up, we'd be able to see our room. Does that make sense for how we draw a net?
Yep.
We will be, in a couple chapters, getting into surface area and volume. Probably not really much till we get close to holiday break, or maybe after holiday break. But we're going to do some labs with that stuff where you like actually break apart 3D shapes to look at the nets and put them back together, and comparing volume. So it gets pretty fun. Oriana. So the roof would be the same dimensions as the floor here. So this space is a 3 by 4 because it was 12 feet by 9 feet. So you could just put the roof either, you could put it attached to any of the sides actually, front, back, left, or right. So if I wanted to put the roof attached back here, it'd be approximately that size. So when you fold the back wall up and then fold the roof down on top of it.
Okay.
Bless you. All right, so now let's dive into what you guys do have on your papers. So we want to identify if this relationship is proportional or if it's not. So we're going to use cards, and I would try to paraphrase these on your paper. What's it mean to paraphrase? Brianna? Abbreviate, write a short version of, but that you can still understand. Emphasis on that you can still understand. So Karina, if I tell you that you buy a number of dog bones Y that is 3 more than the number of dogs X you invite. By the way, the situation here is you're throwing a dog birthday party, which I could see some of you guys doing. So you have X dogs coming. You buy Y bones that are 3 more than the number of dogs. Is that a proportional relationship? No. Why not? Well, you can have more and it still be proportional, but you can't do it through addition. You can't take one of your values and add to it. We'll see what we can do here coming up in one of the next ones. Zach, if you have your age, X, is 8 years greater than your dog's age, Y, is that proportional? It is. So when we write this, your age, X, is 8 years greater than your dog's age, Y. Yeah, it's not proportional because, again, it's trying to use addition. And we can actually rewrite that and say Y, your dog's age, is your age minus 8. Which, again, you see that's not proportional because it has something added or subtracted here. It's got to be multiplication or division to stay proportional. Franny, what about you invite X people and cook Y pounds of chicken. For every 4 invitees, there are 3 pounds of chicken. It is proportional. Now, how we would write that situation, and guys, I would be writing down at least some of these equation examples. So over here, we had the equation like Y is X plus 3. That was not proportional. Y is X minus 8. That was not proportional. Over here, this one gets a little weird. Y is the amount of chicken you have.
3 times 4.
So you have 3 pounds of chicken. So you have 3Y for every 4 guests you have. We could really actually say Y equals 4/3 X. So this equation is a good example that, yes, it is proportional. It's a little tricky to write. But the amount of chicken that you have, actually, wait, you invite X people. It's the other way around. You're going to have 3/4. So this should have been a 3. This should have been a 4. And this becomes 3/4. Because each person will get 3/4 of a pound. And one way to remember that, and what caught me, how do I find M? How do I find, well, first off, what do we call M? It's got that big long name. It sounds kind of complicated, Brennan.
Constant of proportionality.
Constant of proportionality. We can find that by taking what value divided by what value? Remember, Luke? Other way around. Y divided by X. I'd write that reminder on your paper. The more times you write it, the more likely you are to remember it. So here, I was given 3 pounds of chicken, with Y being my chicken, and 4 invitees, with X being my people. So I knew that it had to be Y divided by X, my 3 over my 4. That will really help you in setting up the equations. I guess I'll leave that there for the time being. You have the same number of candles X as your dog's age Y. Eminal?
That would be proportional.
It is proportional. Whenever they vary, so that they vary together. When two things vary at the same, like for every year old you are, there's a candle on the cake. That is a direct variation. So proportional relationships show a direct variation. You have twice as many party hats Y as you have guests X. Katie? Yep. Because that situation would be Y, my party hats are 2 times my value of X. That equation right there would be Y equal to 2X, so it is proportional. So that's another example of a proportional relationship.
There is no check answers.
There is no.
There's a solution.
But if we pull that up, we can see the tables that we can set up. I wish this was a little bit smaller to get more of it. What's that? Got it? Or is there? Yeah, go ahead and try the got it on your own.
Got it.
Just, you want us to explain?
Yes. You guys need to get used to writing out your explanation because we are going to be looking for more and more of that on your math test. So here as the stuff gets more complicated, the first question or two on the math test might be asking you to write explain the process so that you remind yourself what is the process. Like I might say on this mastery, explain how you find the constant of proportionality. And you would say you take the y value and divide it by the x value. Or if you really want a good answer, you could say, to find the constant of proportionality, we can take our value for y and divide by our value for x. Yes. Yes. As stuff gets more difficult, and especially as we have more formulas to remember, we will have open note tests, but I will normally not warn you. So if you're one of the people that takes kind of, half of the notes and you don't always have everything written down, I would caution you to try to make sure you get everything written down. So if I say, and a lot of times it'll be like we have 10 minutes left in the class period, I'll say, okay, now you can use your notes. So you can check any of the answers that you've done or you can look in it and verify. Oh.
I said that this is a proportional relationship because for every 1 inch there's 75.
Yeah, so when I see the relationship of 1 inch compared to 75 miles, that is proportional because then 2 inches would be 150 miles. 3 inches would be 225 miles. So we have this apartment.
I used a scale drawing when I was building this apartment. It'll be handy to use it for furnishing later. Check it out.
All right, so check out this blueprint. Actually, I could have probably, no, your notes aren't pulled up yet. So we want to say, could a bed that is 6 feet long and 3 feet wide, 6 feet long would not be big enough for me, fit in the bedroom shown below? So here's our bedroom shown below. You want to fit into the narrow section of the bedroom below. So we are looking at this space right here, that narrow section. Sometimes people like to kind of hide their bed back away. So we need to figure out what is the real width here and what is the real length here. Because we're really trying to fit it right there. Have a little nook. So take these values and figure out what are the real dimensions. I want you guys to try to solve this.
Wait, so...
You have this scale to work from. 1 inch is equal to 10 feet. 1 inch is equal to 10 feet.
Does it end with a 3/4 end?
If you're having issues, please
Yeah, I can fit.
You know what I'm gonna tell you. So why do I have to tell you?
You should be in
Nice
circus.
No, when I can do that, but I can't always.
Oh yeah, like the marching band people.
Yeah.
Always have
I
those.
can
Yeah,
do
the
it
Ohio
with
State, the baton.
I don't get how they do that.
I
Me
can do it with
neither.
the coin.
Can anyone walk me through either
Mr. Williams to the office, please.
checking the
Mr.
width
Williams.
or the length?
I feel bad for him. He's
Abby? Alright, so what'd you set up?
Oh, I think I did it wrong, so I'm not sure if I want to share.
I'll stop you if I need to.
Don't worry if I did.
I did it a weird way.
4.
Don't just tell me what you did. Like, how'd you get there? Like, what did you write first? Did you make a proportion?
Well, I knew that 1 inch is 10 feet.
So couldn't we start by just writing down that proportion of 1 inch compared to 10 feet?
Yeah.
And then we could set that equal to, do we want to do width or length?
Well, I started.
I think you did the width. Or
4, maybe width.
considering you said divided by 4, maybe you did do the length. So we could say 3/4 of an inch over X feet. We don't know how many feet that is. Here's the thing. I don't really like the whole idea of multiplying by 3/4. That's kind of weird. I mean, we could, but if we cross multiply here, we'll get 3/4 times 10. And here's what's nice. We get 1 times x. So x is already just going to be 1x. So what we get from that cross multiplication is 1x equals 10, and I'm going to put that over 1, times 3 over 4, which equals 30 over 4. 30 divided by 4.
I have a question. 15. Shouldn't you switch numbers around because aren't you dividing?
What do you mean? Hold up. What do you mean?
10 and 3/4. Shouldn't you switch 3/4 to 4/3?
No, because we started with cross multiplication. So it is already multiplication. Don't trick yourself into thinking we have to use the reciprocal. That's if we had started with division. But we started with multiplication. So we get 30 divided by 4. Well, 30 is not a perfect multiple of 4, but 28 is. 28 would be 7. So then I get 7 and a half, and that's going to be feet. So that tells me that this distance right down here is actually 7 and a half.
Mr. Hudson, can I tell you what I did that's like not even right? But
Well, not if it's not even
it's
right.
Like,
Mine's not right either.
I got the correct answer, but I didn't do it right.
Wait, how is that not right?
So like I did like so I know half. So 1 inch is 10 feet. So half an inch would be 5 feet, and then so 3/4 is bigger than a half. So I knew it would be more than 5, and I just like estimated, so I knew it would fit.
Oh, okay. So I liked it up until you said you estimated.
Well,
I would love it if the method that you took, because at first you were great. You said, okay, 3/4. We know that if 1 inch is 10 feet, then half an inch equals 5 feet. So you could say 3/4 is a half plus a fourth, whereas half an inch would be 5 feet, and then half of a half, or the 1/4, would be 2.5 feet, which would equal 7.5 feet. So I liked it up until, but if all we care about is will it fit, then sure, you can estimate. But if we want the actual dimensions, then you could have used this way. But I like your kind of spatial reasoning of saying, oh, well, half of that's just half of that.
I did it a different way.
Okay, you divided by 4, then you multiplied by 3.
No, I just did 10 divided by 4 and then times 3 and then did. I got 7.5 and Is that right?
Well, let's find out. As Karina pretty much just told us, if we know that 1 inch is 10 feet, 1 inch is 10 feet, well, then half an inch, I don't even really need to solve this if my number sense is turned on in my brain, because half an inch is just half of 1, so our length will just be half of that. So this down here is actually 5 feet. We already knew that this was actually 7.5 feet. So will that bed fit? Yeah, it'll have space on both sides too. Because you could have a foot on this side, a foot on this side, and then your 3-foot bed. This is not drawn very well. And then you'll still have space down here.
To get your readings.
What about a blanket?
Yeah, he will.
You're pushing
One
it a
foot
little,
nightstand
Eli.
can go on either side.
Here's my dog on the foot of the bed. All right, so yes, it will fit. Try this. Our scale is the same, 1 inch to 10 feet, sorry. We now want to figure out the area of the wall. So in the apartment, the walls are 9 feet high. You want to put a double coat. A lot of paint, it'll say like apply 2 coats for good look or whatever. Or some of the paint now says you don't need 2 coats. 1 coat will look nice, but that you're going to pay more for that paint. So we're going to use a double coat of the paint on the longest wall of the living room. So let's identify the longest wall of the living room. It'd be this right here. Because we can check this wall right here. If we come over to the right side, that wall would be this distance, 1/2 inch plus 3/4 of an inch. Would only be 1 1/4. So obviously the 2 inches is my longest wall. So you need to first figure out what's the actual length of that wall. Well, if it's 2 inches, we can set up that ratio again. 1 inch is 10 feet, but again, if your brain is turned on this morning, you probably already have this figured out. 2 inches, class, is going to be how many feet? 20, because it just is double what unit is used in my scale. So this wall is now actually 20 feet. How tall is it? 9 feet. So to find the area of that wall, it would just be my 20 feet times my 9 feet is 180 feet squared because it's area. But now if I want to paint a double coat on that wall, I would then have to take this and double it. So we're really gonna paint 360 feet squared. Is it enough paint? No. However, it's so close, we could maybe make it worth, but mathematically, no, it's not enough. So if you, and this is where the paint stores will get you sometimes, if you took in this problem to a paint store, they'd say, oh, you need 2 gallons. They probably would not tell you, oh, you're only 10 square feet away. When I paint, at the end of the paint can, I'm like scraping the paint out with a like paintbrush to put it in the pan so I can roll it on the wall. Like I get every drop of paint. We literally, my wife and I, we were looking at touching up a wall the other day. We're like, oh, we don't have any of that paint left. And the problem is when you get paint made, we were talking about the proportional relationships of paint, the color will probably change really, really slightly. Because the computer, it's very hard for a computer to perfectly, like with 0 error, measure out liquids. You guys should, if you ever go to Home Depot or if your dad or whoever is going to get paint, go watch how it works. They put in, like, it's essentially white paint into the computer thing. It spits in all the colors. They put the lid back on and then it shakes it like crazy, and then it's whatever color you asked for. But it'll spit in like a certain amount of green, a certain amount of blue, like really the primary colors are red, yellow, blue. So sometimes you can make your color with just primaries. Sometimes you have to use some of the secondaries, but it's all proportional, or it's all ratios, how much paint it uses to make certain colors. Brennan?
My dad, not my dad, my grandpa, past couple summers, I've been down there and he paints for like
Yeah.
sometimes. So I think he retired. He was a bus driver for like 40 years.
See, and those guys, they just buy like 5-gallon buckets and they just go until like
He
until
and his
they.
friend. I don't know if they really were the fourth there, but they did it.
Yeah. Let's do one more problem really quick, sir. We'll take that as soon as we get done with this. Before your trip to China, you want to exchange $1,500 US to Chinese yen. Your parents are giving you a little bit of spending money to go. Which bank has the better exchange rate? Now, this might be like a bank in China compared to a bank in America. Now, although everybody should be operating under like pretty close to the same exchange rate, some banks will update every week as opposed to every month. Or like, so it depends on how often the banks update their exchange rate. So do we want to solve yen per dollar or dollar per yen? And I ask you to look at the graph, not the table. Look at the graph to make that choice. Which would you rather do, yen per dollar or dollar per yen? Eli? Why?
Because the U.S. dollar is on X.
Yeah. So to find our constant of proportionality to use in that equation, which we actually call m, reminder, it's your y value divided by your x value. So since your Chinese yen are the y and your dollars are the x, we'd rather do yen per dollar. So over here in Bank A, let's do yen per dollar. Well, I can take 384, divide it by 60. 6.14, you said? 6.4. So you get 6.4 yen for every dollar you exchange at Bank A. Bank B, let's find a point that works nicely. This point right here at 65 yen and $10, that seems to work nice. If your brain's turned on, you don't need a calculator. It just move your decimal. So there you get 6.5 yen per dollar. Which bank is better?
Bank B.
Bank B. You get an extra 1/10 of a yen for every dollar you exchange.
That's a big.
It'll make a big difference with your $1,500. All right, thank you guys. Have a great day. I will get your homework posted by AO. Reminder, only do one.